Right, so thank you so much. I'm going to switch over to Sarvesh now. And Sarvesh's project is one of those really interesting ones that pops up from a student who decides they're going to come to us with a proposal of their own suggestion linked with an interest that they already have, because Sarvesh has already an impressive list of things that he has been doing. Some of them, I think, also linked with this particular project that he's been working on to do with research into diagnosis and prognosis of people with colorectal cancer. He's also the son of Prabhu, who has joined us today to listen to Sarvesh speak. And also we have Sarvesh's mother here as well, Tamil, who I was talking with at the very beginning of this journey, when we were hoping that Sarvesh might be able to join the HPCC Systems Intern Programme right at the beginning of the year. So his mentor has been Bob Foreman. I know that Sarvesh has been using our GNN bundle, and Bob was a really good choice as mentor for this project, because I think probably this is the third year running that Bob has mentored a student who has been using this particular bundle. So that's why he felt like a perfect choice for you. And this partnership does seem to have really paid off really well. So I'm just going to hand right over to Sarvesh now. So if you want to share your screen and tell us all about your project and what you've been achieving over the last 12 weeks, Sarvesh.
Absolutely, thank you. Is the screen share working?
Yep.
Yes, it's working for me.
Yep.
All right, fantastic. Good morning, everyone. Hope you're doing well. My name is Sarvesh Prabhu, an intern at the HPCC system. I just entered my senior year at Lambert High School. For this summer, Mr. Bob Foreman was my mentor, and my manager obviously was Ms. Lorraine Chapman. I've always had the unique interest in business application in machine learning and its pragmatic use cases. Of this, I've built 3 business models to date, and in one of them, I have a provisional patent on the technology. Now, this internship is about one of the 3 business models, Parva Capsula, a revolutionary transformation in the gastroenterology practice. I presented this vision and business model at the startup competition initially at the University of North Georgia, and won first place and some grants to make it a reality. This internship is my first pragmatic step in the technical implementation in the grander scale. Now imagine, a patient is admitted into the emergency room at 1 a.m. with a detrimental stomachache. It's going to take several hours of diagnosis before the patient gets to see a GI doctor in the operating room. And the last thing the patient wants now is to stick a probe with a camera from the rear when he's already in severe chronic pain. The actual treatment begins only after the GI doctor diagnoses the problem. Now, according to the American Gastroenterology Association, it takes up to 14 hours for the GI doctor to share the diagnosis. Meanwhile, in most cases, all the patient receives is only pain medication. If you view the gaps in the market now, for the patient, this is elongated pain. And the GI doctor had to wake up in the middle of the night to come to the hospital for this emergency procedure. For the insurance carrier, it costs money the longer the patient stays in the hospital. And for the hospital, it's prime real estate that can be given to other patients. My solution is Parva, a swallowable smart pill. Now, the pill contains a camera and communicates to a smartphone via Bluetooth. The patient takes it as soon as they walk through the emergency ward. The pill takes pictures and videos at 6 frames per second as it travels through the upper and lower GI tract through the body. The pictures are then analyzed for areas of interest, which I call biomarkers. Now, this research empowers practitioners to reach a faster conclusion for patient treatment, several hours in advance compared to a traditional scope, all while being non-invasive. Now, on the left, we are looking at the actual videos and pictures captured by the pill cam as it tumbled through the GI tract. I have procured around 23 hours of this video for this research and for when my Netflix subscription ends. Now, for a data scientist, this was a gold mine of a data set. We all know deep learning is the solution that uses convolutional neural networks, and the diagnosis too. Voila, right? Well, we have a challenge. Current machine learning models are not trusted by practitioners due to accuracy not being up to the medical community standards. After all, a false positive wastes both money and precious hospital real estate, and a false negative often leads to the tragic loss of a life. We as technologists have a social responsibility and have the right skills to address this gap. Thus began my research and internship with the HPCC systems to achieve the highest consistent accuracy in diagnosing colorectal cancer, made possible by utilizing HPCC's expansive generalized neural network bundle and learning trees bundle. Let us review my dataset before diving deeper into the model composition. For your curiosity, these are the physical devices used to capture the images and videos. To your left is the capsule, around the size of a Dayquil pill. On the right, they use a small recorder that the patient wore on their belt. In my model, it communicates through a smartphone and pushes the results to the appropriate EMR software at the hospital through the HL7 interface. It's pretty cool to see these physical devices for real, isn't it? It's 100% safe and approved by the Norwegian federal authorities as of right now for human testing. I began my data procurement from an open source GI library called the Hyperkvassier, the largest gastroenterology dataset in the world. The data is derived from a smart PhilCam footage as it travels through the body of various patients at the Byrom Hospital in Norway. The footage covers both the upper and lower GI tract. Experienced gastrointestinal endoscopists partly label it. The dataset contains around 110,000 images and 374 videos and represents anatomical landmarks and pathological and normal findings. The small PhilCam captures videos at 6 frames per second, totaling around 7.74 million pictures. Each image is around 336 by 336 pixels in size for consistent use with the model. Now, the pre-annotated labels describe the points of interest in the forms of biomarkers. That being said, polyps, ulcerative colitis, and colorectal cancer. Now, there are several others in the GI tract, but for the purpose of this specific research, I limited to just 3 diagnoses. I wanted to ensure I call out the permissible use of the data before model preparation. The hospital fully anonymized the data before they made it available outside their EMR software. It's also compliant with the Norwegian privacy data protection and GDPR. The hospital managed the bias removal and proper distribution of the data by gender, age, and ethnicity. The data is not pre-processed or augmented in any way. This is important for accuracy in the deep learning. The hospital also wanted to call out that the data collection did not interfere with the care of the patient, and there is citation associated to it as well. First, in my model journey, I wanted to ensure that there is no noise by eliminating the blurry and low resolution of the images. I used a confusion matrix to sort out the best and most accurate of the images. For this research, I picked 1 million out of the 4.7 available to me. Next, I set up the success criteria and scientific objectives to determine the accuracy, in this case in the form of precision and recall. Thanks to my AP Statistics class, I picked F1 score as a way of measuring accuracy. Then, I wanted to ensure that I statistically accounted for the true and false positive and negatives, and is a balanced measure. This is achieved through the MCC, Matthews Correlation Coefficient. I used HPCC's generalized neural network for feature extraction and the first imagery diagnosis model. The generalized neural network bundle consists of a convolutional neural network with a TensorFlow embedded over the Keras framework. To process the 336 by 336 pixel images, my tensors were set to 3 channels, 60 rows, and 60 columns. I used a 78 by 22 train to test ratio for the experiment, using the Adams optimizer descent algorithm for training and binary cross entropy as my loss. The model utilizes Adams for training and passes the input to the binary cross entropy model through the kernel convolution. The metrics used to measure the output are precision and recall. With hypertuning, the GNN model yielded 76 to 81% accuracy. Not too impressive for a healthcare environment, and definitely not something we can depend on for patient care. So I proceeded with the research using the random forest model, thanks to Mr. Roger Dev's advice to tell me to think through this angle. RF is the most popular tree-based algorithm for classification use cases. The random forest utilizes the image labels to detect biomarkers and therefore diagnosing colorectal cancer over multiple decision trees in a forest pattern. The inputs are classified and cross-verified over 24 trees with 2 variables per tree. The random forest model utilizes the exact same 78 to 22 train to test ratio with the max depth at 255 and the forest size at 10. It utilizes precision and recall as metrics, and we were able to attain a Gini index between 0.39 and 0.5. I now have 2 different models performing the exact same use case with the same output. Now, it's time to develop an algorithm that yields consistently accurate results. My experimentation contains 3 parts. First, execute the GNN model inference 1,000 times for every raw image acquired by the smart pill with optimized parameters for each run. Accuracy was 80.6. It's better. Second, feed the GNN biomarkers and predefined labels to a random forest model, attaining the most confident outcome by counting the most votes for the conclusion. Accuracy then improved to 92.3%, much better, but not industry standard. Third, further improve the accuracy by broadening the input to not just one image, but a collection of images. So I traveled 3 seconds forward and 3 seconds back for every image to get a
Sarvesh, I think you've hit the mute button. So we missed you. Do you want to start so I traveled 3 seconds before and 3 seconds after again, so we don't miss what you're saying?
Yes, sorry about that. So I will start. So third, I further improved the accuracy by broadening the input to not just one image, but a collection of images. So I traveled 3 seconds before and 3 seconds after for every image to get a cohesive view, angle, and lighting conditions for the optimal smart pill cam. The smart pill cam I used for this research yielded 6 frames per second, allowing 36 images to explore for the model. So for each of the 36 images, I used the GNN bundle to retrieve the biomarkers and feed the input vectors to the random forest, boosting the precision to a 99.8 accuracy rate, an unprecedented number for this field of research. So my final verdict, the research concludes that ensembling the GNN and multi-layered random forest yields the highest accuracy and consistent results with a 99.8 precision rate and 100% recall, enabling the practitioner to make an informed treatment decision using a non-invasive smart pill for the patient in need of urgent care. I'd like to sincerely thank my mentor, Bob Foreman, Mr. Roger Dev, and my awesome manager, Ms. Lorraine Chapman, for being such fantastic help throughout my HPCC journey. Without them, I would not have had the opportunity to give back to the practitioners and hospitals, saving tomorrow's lives today. Thank you.
That was amazing, Sarvesh. I think when I started your introduction, there must have been a lot of people on this call who actually didn't really know what they were going to get. And I did that on purpose, really, because this is such an amazing project that you have been working on this summer. It's a wonderful use case for HPCC systems and our machine learning bundles. And I think it's absolutely wonderful that you've had an opportunity to try and use our system and our machine learning bundles in different ways to get those really amazing results that you have just shown us at the end. I'm not an expert in machine learning. To me, this just looks like an outstanding piece of work that I feel completely impressed with, not only from the perspective of the work that you've done, but I feel like your knowledge of machine learning is really very impressive indeed. And this is a piece of work that I think, well, how old are you? Tell everyone how old you are, Sarvesh.
Yeah, I'm 17. I just turned 17 a few weeks ago.
I mean, I just feel like this piece of work that you have done would sit very nicely with someone who might be studying a master's or potentially even a PhD. I just think it's an astounding piece of work, and you are just the most amazing person of your age to even attempt a project like this. And I want to thank you for bringing this to us and using this as such an amazing use case for HPCC systems. And I don't know if all of you on the call know, but Sarvesh will be bringing his presentation to the conference this year so that we can showcase this into a wider arena. And I do think it's extremely well deserving of being awarded a place on that. Now, I can see that there are questions. I can certainly see there's one from David. David, do you want to go first while I just see if there are any others in the list?
Yeah, I think Ming had his hand up first, but go ahead.
Oh,
David.
yeah, he did. Oh, did you? Sorry, Ming.
Okay.
I wasn't able to see that. Please go ahead.
Go ahead, Meg. No problem.
Thank you. Yeah, great job, Sarvesh. I have a question. So, do you use the predefined model, or you created the CNN model yourself, the layers?
Yeah, so there was a GNN model that was graciously created on the ECL repository. I was able to take that and hypertune it and modify it for our specific use case.
And how many features you get from the CNN training?
Yeah, so from the initial training, I was able to gather around, like per image, around 10 features, and then these were put together back in coordinates that were identified specifically for the random forest.
So you think the 10 features can uniquely identify the image you want to process, right? It's 10,
yeah,
only the 10 features? Okay.
Yeah, so it was 2 coordinates for each part of the rectangle that was identifying the biomarker, and then 2 on this other corner. So that would be the identifiable features for each image.
Have you think about if you increase the features instead of go to the random forest algorithm, just use the CNN or GNN to process to get a better result?
Yeah, I think you make an excellent point there, Mr. Ming. That was one of the biggest points, that the number of features, as well as I could have processed the TensorFlow chromatically rather than using channels, rows, and columns. That's something I'm definitely going to look into with my further research with GNN.
Have you ever tried to train your model on your local machine without the cluster?
Yeah, so this was run on a local cluster that I remotely connected to. I was initially on a Kubernetes cluster, but I transferred on to local after a month or so.
So what's the resource on your local cluster? The CPU and the memory?
Yeah, so my local cluster is on a GPU, and it has 32 gigabytes of RAM, as well as the machine next connected to me has another 64 gigabytes of RAM.
Oh, so you use the GNN with GPU, is that right?
Mm-hmm.
Okay, great. Yeah, thank you.
So Ming takes no prisoners there. You did very well, Sarvesh. That was very good. So now moving on to David DeHilster. Do you want to ask your questions?
Yeah, absolutely. Great project. Really, really great. Has anybody else tried this? And if they have, what did they use and what were their percentages?
Yeah, so the biggest thing I read before getting into this internship was an article by Nature. They ran a convolutional neural network model on Python using the ResNet 159 and ResNet 161. Their accuracy was around 96.7%. I'll actually link the article right here. It's a fantastic article. That was the biggest source of colorectal cancer diagnosis before this. I think my biggest implementation was the use of HPCC's bundles and the random forest, the multi-layered random forest is what was able to get me higher than their accuracy rate.
Okay, thank you very much.
Any further questions for Sarvesh about his project? Seeing any further hands go up. So at this point, I want to bring in Bob, who is Sarvesh's mentor, just to speak a little bit about how the whole internship went from start to finish, and how you feel about, you know, where Sarvesh started and where he's got to now that he's completing his internship.
I've done this for 3 years now. It's my third year, and not to disparage the other interns I work with, but Sarvesh raised the bar. He was exceptional. He started his internship before his internship actually started. He started doing the research even before his first week. I used very little. All I had to do was point him to a couple of examples, and he took off from there. It was for a mentor, it was the smoothest mentor I ever had. I mean, he just was such a self-starter. When are we going to bring him on to LexisNexis? That's what I want to know. When are we going to give him a cluster so he could really flex his muscle on these images and really work with the whole, you know, let's give him a big cluster to work with. You know, we gave him a sample cluster to work with, but now, you know, now you see the research, you see the results he's getting. And we definitely we need to support him, and we need to, you know, I don't want to lose him. He needs to be part of our team. He's just a phenomenal colleague and developer, and he's got a great future ahead of him. So, you know, it was just, you know, I'm just amazed at the work that he did here. And just once again, Sarvesh, you know, kudos for you. You're just, you're cut with the right cloth, and you need to be part of our team as soon as possible. All right.
Thank you. I definitely could not have done it without you, Mr.
I don't know if we're going to be able to afford you though.
I was thinking something similar, to be fair. But also your passion, Sarvesh, as well. It's obviously something that you are extremely passionate about, and that really shone through for me in your presentation. I want to just bring Roger in here, because Roger, being the leader of the machine learning library, I'm just thinking it must be so wonderful for you, Roger, to see parts of our machine learning library being used to the extent that Sarvesh has been using it. And I just wanted to ask for your perception on and your awareness of what Sarvesh has been doing, and how that's really helped maybe improve on the bundles. Have there been things that you've had to kind of look at along the way to fix? Because I'm kind of thinking that not only has Sarvesh contributed an very interesting use case here, and an impressive one, but also potentially feeding back into the improvement of the machine learning libraries as well.
Yeah, extremely impressive what you've been able to achieve, Sarvesh. You know, we basically gave you a few hints as to a direction to start in, and you ran with it and took it all the way. And the amount of research that you achieved in this amount of time was very impressive. Certainly, you couldn't have done it in 40-hour weeks. I think you put a whole lot of your own time into that. It was very, very good, and I'm really proud of what you accomplished, and that you're able to do it with our bundles. And I don't think you actually had too many problems with the bundles themselves. I don't recall having to make any changes. Yeah, so that's very encouraging for me, that you're able to do all that with the existing bundles. So
I
thank
do
you.
know that there were issues with clusters, and Bob and I have talked about this quite regularly throughout the course of Sarvesh's internship, and I am kind of hoping that some of those issues will go away as we move forward in the future. Last year we had a situation where if students couldn't get on a cloud cluster for whatever reason, they still had access to a bare metal cluster, and of course this year quite a lot of those bare metal clusters have gone, and so we have been having to use a cloud system, and unfortunately they've been few and far between and not necessarily easy to access. So you know, it's just something to bear in mind for next year's intern program, that we probably do need to make sure somehow, I don't know who the right people are to contact, so I'm putting this out there, seeing as there's quite a lot of you on this call. If you do happen to know who we could approach to make sure that we can get an effective cluster for students to use next year, then that would be highly beneficial to the success of projects in the intern program. Sarvesh has done a great job in sort of making do with what he has had, and I can't even begin to imagine what he might have been able to do had he had a cluster that would have been more fitting to the job. So kudos to you, Sarvesh, for being able to do that. Lastly, I just want to bring in Richard as the leader of the platform project, because I just think this is a really amazing use case of this platform that all of you who are on this call today contribute to in some way or another. But as the leader of the team, I just wanted to give you an opportunity to jump in here.
Well, I'm not sure what I can add to what's already been said. Very impressive, very, very impressive. I'm sure you have a very bright future ahead of you. Yeah, great presentation. Two great presentations actually, but yeah. Thank you.
Yeah, because I do think, going back to Shivan's, the work that he has done has also contributed greatly to the open source project, hasn't it, Richard? So I think that you know, we have been very lucky this summer in all 11 projects that students have worked on. But it's been really great to focus on the two projects that have been presented about today, one being a use case and one actually being an effective enhancement to our open source offering.
Yeah, I mean, not just today, there's been some very impressive presentations on all the intern projects this year. Must be down to the skill of the intern program organizer.
Yes, it must, mustn't it? I very much doubt it. All I do is sit here and put all the pieces together. I find it astonishing every year that I sit here and listen to the presentations at this point in the programme and the impressive work that all of the students achieve. But I do want to say a huge thank you to both Shivam and Sarvesh for joining our programme this year and for contributing so much, and also to the mentors who have supported them, to Bob and to Roger and to Lily and all the other team members that have had an input in whatever way, whatever support that the interns needed. I always know that you're going to come up and come through for me and support them, and it's what keeps this intern program strong and helps the students get the results that they do. I'm incredibly proud of everything that each student has achieved this year. I'm incredibly proud of the two students who've presented to us today. I don't think I'm as proud as two other people who are going to be on this call, seeing as Sarvesh's parents are both here today. So I just want to have a nod to them, because obviously we've known Prabhu for years, and it was really lovely to also speak with your mum as well, and put all the pieces together to get you here for this particular internship. It's really great when we can support the children of the people that we work with. We do actually do this every year. There are always at least one, maybe a couple of students that we support every year whose children have an interest in technology and clearly have bright futures ahead. So it's really great. Thank you both to to Prabhu and to your mum for helping to connect the dots here, and they deserve to be extremely proud of the work that you have done. And Shivam, you should also have a nod to your family. I know things have been very difficult for you in recent years with COVID-19 interfering with your ability to even get on this programme, even though we desperately wanted that to happen. I'm really glad it happened for you this year, and thank you so much for persisting and for completing what's an important project for our open source initiative. So Prabhu, if you want to stop the recording now.
Oh, certainly.